Okay, with this part you're gonna see some heavier turning. So this will be the part that connects the pipe to the shaft in the upside of the pole, or whatever it's called. So again, this is a piece of mystery steel. I have no idea what the grade is. The diameter is 120 millimeters. And I'm trying to dial it in. Let's see if we get any luck. Getting close on this side. A little over 3, maybe a little over 3. And this side is, oh, there's a really big dent in here. So this is a little over 3. This is a little under 3, so tighten the other side just a bit. Oh, it's almost loose still. There's a really big dent in the piece. I think the average is pretty good now. Let's do a tightening turn. Okay, that's it. Ready for some turning work. Okay, let me get set up. Okay, another one of my rough drawings. So this is what the piece is gonna look like. It's gonna sink into the pipe. So this diameter, oops, this should be 107. This diameter here will slip into the pipe, and here will be weld. Actually, I have to bevel these for the welding, and it's gonna have a 59 millimeter hole in it, so that I can slide the shaft in, and I can weld it here and here. And also this is gonna have a press fit or a shrink fit. Not sure if I'm gonna heat it or press it. And the outside diameter is the same as the pipe's diameter, which is 115. And this means that you're not gonna see some very heavy turning. So there's only 2.5 per side to remove here, and a little bit more here, but it's not very much. But there will be a time when this tool is gonna see some heavier work. Let's get set up. I'm using the same speeds and feeds as last time. In other words, the speed is 360 and feed will be 0.28. Okay. Let me get my glasses. Okay, first straightening the face, and at the same time I'm getting to recheck the tool height, which should be correct, but I haven't checked it. millimeters. Perfect center height. Okay, the face is now cleaned with a great surface finish. And now it's time for the outside. Always have to double the feed when face cutting. I mean using the crosslight to feed. Just trying to get a diameter reading first to see where we are at. $120 and a little bit over. Yes, so 5 millimeters to go. Let's take one, two, three. Let's zero first. Let's try 4.5 of diameter. Actually, let's go with 5. We should still have some material for finishing. This again is one of them not critical dimensions. It's just supposed to be the same diameter as the pipe's OD. Hope you got a good view. Let's go! Oh yeah, that's beautiful. This is by far the cleanest cut I've had for a long time. Look at these chips. Beautiful. Still smoking. some on the floor also. And the finish is awesome. Really happy with this. Beautiful finish and beautiful chips. And it feels like it's good for much heavier cuts. Okay. Now let's turn the part that goes inside the pipe. So we have, I think it's 4 millimeters per side, because the wall thickness of the pipe is 4 millimeters. I thought it was 5, but it's only 4. This might be a good angle. So we are going 25 millimeters, 35 millimeters long. By the way, the outside diameter is exactly 5 millimeters larger, so we still have about 25. But I'm not gonna take it. It's just fine like this. So. 8 millimeters of diameter to go. Let's dial that in. I think I'm gonna try to take it in one pass. So it will be 4 millimeters per side. That's a pretty nice cut. Okay, this is one heavy cut for you. Let's see how it goes. I'm gonna recheck the tightness of the jaws first. Feels very good. Okay, let's go. And this is gonna put some strain on the lathe. Okay, I was liking it so much that I forgot how far we were supposed to go. So I think we went too far. Let's check. 4 millimeters too long, but that doesn't really matter. It's only that maybe I'll have to move the piece in the chuck to get access to some more material. But that was a really nice cut. Finish is also great, and the chips are magnificent. Beautiful chips. Okay. And let's measure 107.2. So I think we still have to take a little bit. Let's take half a millimeter, so it should slide in pretty well. Okay. That was too light of a cut for the chip breaker to work. So this is, I should have used the finishing insert. Okay. Okay, now chamfering the edges using this square insert tool. Big chamfer. And another one here for welding. Okay, now we will start drilling. Removing the drill bit. And installing the drill chuck. And using a center drill with, I think it's 3.5 or 4 millimeter by 10 millimeter. And let me wipe the waste. Okay, going for a center hole. Next is a 14mm twist drill. Okay, now we have a 14mm hole. We're gonna skip a few sizes and jump right to the big boys drills. And this is a 55mm drill, so it's a little over 2 inch. Okay. It's got a new grind on it, but I don't think it was done by me. I have no idea if it's sharp or not, but we will soon see. This is a pretty fine sized drill. and I have 40 RPM. Let's see how this bad boy does. Some oiling. Phone is ringing. Okay, ready to go. It's not perfectly sharp as you can see. One side is making good shapes, but the other one is not. Okay, I run out of pilot hole. This is a pretty nice chip, I think. Must weigh like 100 grams or more. I never understood why you have to drill a hole in many pilot sizes. To me it's like using this late insert right here by taking only half a millimeter cuts, many half a millimeter cuts. It only wears out the edge when you have the whole edge to use. The same with drills. If you have many pilot sizes, you're only using like a few millimeters or a few hundred thousandths on the edge right here, and none of this. So if you have a powerful enough machine and rigid conditions, why not just go from the pilot hole to the size that you like? Of course, taking into account that the web size here is not larger than the pilot hole. Turning the inside 4 millimeters larger. Not ringing this time, which is good. So 59 is the aim, and now we are at 57. So let's add in 1.5 millimeters, so we should have half a millimeter to take off for the finishing pass. Pretty good this time. Half a millimeter to go. Again, this is not critical. Again, what is critical is that I make the shaft to fit this board, and I'm gonna use some micrometers and bore gauges and everything to make the fit good. Exactly 59. At least by the caliper. Now I'm gonna part it off. Okay, the parting distance is so long that I'm gonna have to use this tool with an adjustable blade. It's just that the insert's got a special grind by me, because this is the one and the only insert that I have for these Seco tools. I have a ton of these blades and other Seco parting tool equipment, but I don't have any inserts, so that's something that I'm gonna have to get soon. Another possibility is to get some Sandvik tooling for parting also, but since I already have these, I think it would be a good idea to use them. But the first thing I'm gonna do is do some edge rounding into the bore in this way. Now switching down using 180 RPM again. And the feed will be very, very slow. It's gonna be 800 per revolution. Okay, let's see how this does. I've also ground the insert in an angle so that it doesn't leave any burrs to the piece that's being cut off, but it also makes the tool want to bend. So let's see how this goes. I hope the low feed helps. Also I'm gonna use some oil. Let's go. We actually made it. Great. It looks like I also oiled the camera lens pretty well. The surface finish is pretty good. If you can see anything. Let me clean the lens.